Hi, my name is Lauren Kong, and the problem I'm going to be doing is number 45. Objects with masses m1 equals 10 kilograms and m2 equals 5 kilograms are connected by a light string that passes over a frictionless pulley as in figure P430. If, when the system starts from rest, m2 falls 1 meter in 1.2 seconds, determine the coefficient of kinetic friction between m1 and the table. So first, I needed to figure out what that figure was, and it is this one. So I started by drawing a diagram. So here's my diagram. We know that m1 is 10 kilograms, m2 is 5 kilograms, and I drew all the forces. The forces for m2 specifically is weight, and it's counteracted by tension that's going up. As in friction is here, tension is here, the normal force, and the weight. And I put the direction of motion for both as the positive direction. So first, I wanted to look at M2 because it gave me a lot more information which I can use since it's a connected pulley to solve for M1. So the first step is to find the acceleration of M2 using kinematics. So we know that it's falling, and this acceleration is going to be the same as the acceleration in this direction because it's connected by a pulley. So I know that it starts from rest, which means 0 meters per second. I know that the distance it falls is 1 meter and the time is 1.2 seconds. So I used this kinematic and I solved for acceleration of m2, and that would be 1.39 meters per second squared. So the second step is that now that I know the acceleration, I can now find the tension, because the tension here is going to be the tension here, which counteracts the friction, which I'm trying to find. So what I did was I used Newton's law, and I just did the sum of the friction equals the weight minus the tension equals mass times acceleration, and that acceleration we found previously. So I used that and I found tension equals 42.05 newtons. So that's this tension as well as this tension. So the third and final step is to find the normal force. The normal force will help us find the friction because the friction equation is friction equals the coefficient of friction, which we're trying to find, times the normal force. So this equation is the normal force minus the weight equals mass times acceleration. We know that since there is no acceleration in the y because it's not floating in air, we can find out that the normal force is 98 newtons, which means that we can go to our final equation, which is trying to find the forces of this direction, and that would be the sum of the forces in the x direction equals the tension, which we found already, minus the friction equals mass, 10 kilograms, times acceleration, which we found previously. And so if you solve for this, you can use the friction equation, and you find out that the coefficient of kinetic friction is 0.287.